There's a few things that I definitely want you to understand about the atmosphere. It's not as thick as we think it is. Okay, so oftentimes when we look out, we're like, oh yeah, it's really thick. How can we pollute all that? Pretty easy, because it's not as thick as you think it might be. So the first thing I want to talk about, we're going to break this up. So these are the different layers of the atmosphere. We're also going to have the layers over here, but we're going to show you how the temperature changes as you go up. And we're going to talk about what happens as you go up in miles. So we have 0, 7, 30, 50, 300 plus, and then out to space. One that you breathe, you walk in, all that other good stuff. Start with a T. Troposphere, good. Troposphere, troposphere. So the troposphere is the one that you live in. This one is probably the most crazy out of them all. Okay. Ever fly in a plane before? Okay. Never have? Man, you're missing out. You're going to love it. I love flying in planes. So when you take off in a plane, is it smooth or is it rough? It's really rough. You take off and it's like, not really. It's probably going to always be rough. And here's why. Even if we have good clear weather, it can still be rough. And the reason being is the troposphere contains all of the Earth's weather. This is where all of the weather exists, is right here. So when we talk about weather, weather is the current condition of the atmosphere. So you stick your head outside and you're looking at weather. That's what it is. The weather can change in 5 minutes. It was different 5 minutes ago, but it's currently right now what it is. So what all does weather include? Obviously, rain, snow, sleet, hail, clouds, but it also includes wind. And wind's something you can't see. You can see it if you know what you're looking for, but even on clear days, can you still get wind? Yeah. And the other thing is if you want to see something really complex, even though it's not windy down here, is it windy up above? Yeah, it's super windy. To understand winds in the troposphere, you can have wind going this way, you can have wind going, you go up a little higher, now the wind's going this way, go up a little higher and the wind is going this way, this way. Every layer, the wind changes direction. So those guys that you see in the hot air balloons, they have to understand what the wind is doing above them, because that's the only way they can steer those things. So they go up higher, the wind blows them one way. If down below they notice the wind is going another way and they want to go that way, they have to drop the balloon into that wind. So if you watch them, they're constantly moving up and down in the air because they're trying to catch different wind patterns to blow them in different directions. So bottom line is, have you ever taken a car and been behind a diesel? And how's the car feel? Yeah, like you're in this tunnel type thing. That's the way it is when you take off in a plane. You're going through all of this different wind as you go up, and it will actually move the plane all different directions. In a commercial airplane, we don't actually fly in the troposphere. We fly through it, but we don't actually fly in it. We fly up here in this layer up here because there's no weather or wind. But if you ever fly in like little puddle jumpers, meaning like the two-seater planes and stuff, they're horrible. They're rough. Anybody ever fly in one of those before? Pretty rough? Yeah. It's like, so we have weather in the troposphere. A few things that you can actually see. So we have this line up here. This line is called a pause, and it always takes on the name of the layer below it. So this would be called a tropopause. And the tropopause is literally like a lid. It does keep everything contained. So like when you have weather here, this weather, you can see these great big clouds that form, but if you ever see like a great big thunderstorm that comes in, if you ever notice it has a big flat top to it, okay, that's because it's hitting the top of the tropopause. It's right at the boundary between the troposphere and the stratosphere, and so it flattens out because it just has a hard time getting up into the stratosphere. However, in these storms, you have air that's rising, and then you have air that's sinking. And if that air is circulating fast enough, it can cause a little bump to form at the top. And what you're seeing is that wind travels back down. And it can do that. There's one type of volcano that can eject material all the way up into here. It's called a stratovolcano. And that would be like your Mount Vesuvius, Rainier, Mount St. Helens. They're called stratovolcanoes because they can eject material up into these upper levels up here. Temperature-wise, so 20 degrees down here in Celsius is really like 68 to 70 degrees Fahrenheit. And as you go up, the temperature actually drops to about negative 40 to the top of those clouds. So it gets colder as you go up. Most of you probably know that if you lived here long enough. Out in the hot summer days, the best place to go is where? The mountains. Go up the mountains, and yeah, it's nice and cool. Sometimes it can be July, and you'll be up there, and you still have to have a hoodie or some kind of jacket, because at nighttime it can get pretty cold. Yeah?
Isn't every, like, 10 degrees you
It's a degree for every 100 meters. Yeah, or 10 degrees for every 1,000 meters or 1 kilometer. Yeah, so it does drop quite a bit, and there is a very big difference you can feel in that. So the next layer is called what? Oh, by the way, the troposphere is only 7 miles thick. When you look up, 7 miles is really hard to be able to identify how high that is, because when you look up, you don't have anything to actually gauge depth from. It just keeps going out to space. But if we turn it sideways, from here, where would 7 miles put you? What do you think? Yeah, probably Provo, maybe just a little bit further. So think about that from here to just a little past Provo. That's how thick this layer is. That's where all the weather takes place. That's where all the storms take place. Is it that thick? No, it really isn't that thick. And you take that and now stand it up. That's how thick this layer is. This is the layer that keeps us alive. That's the one that we really depend on, is that 7 miles. So when we talk about pollution, how much would it take to pollute an area between us and Provo? Not a lot. So when we talk about the atmosphere and we need to keep it clean, we really do need to keep it clean, because we only have 7 miles between here and what potentially could be death for us. Yeah, it's not that thick, so we really need to be more aware of what we're doing and try to keep things clean. The next one is called the stratosphere. And the stratosphere is not, even though it's the ride down in Vegas and you have the Space Needle and all that stuff in Washington, the stratosphere is actually a layer in the atmosphere. And when we fly planes, commercial planes, we like to fly just above this, and we will fly them right in through here, because there's hardly any wind, and it makes for a really smooth ride. So we like to fly right into that area. When you fly a plane, have you ever noticed that everything's good and then all of a sudden the plane feels like it drops? Okay, let me tell you what that is. Do you think that line is perfectly straight? No, it's not. So what happens is when you have stuff like that, this line may actually be up like this and back down and up and down. So you might be flying straight, but then when you hit that, it's like hitting a speed bump, and the plane will kind of skip. And that's what you feel. Or it could drop. That's all you're feeling. Has nothing else except you just kind of hit a speed bump, or we call that turbulence. And that could just be air that's moving up and down and kind of pushing that boundary in between the two. But it's nothing to really worry about. All it is just a change of you're going from the stratosphere back into the troposphere. You'll notice when they do that, watch what they'll do with the plane. They'll actually go up higher. They'll bring it up higher and higher and higher until they feel like they're safe, and then they'll bring it back down. Yeah. Look at the temperature when you come up here. It kind of flattens out, and the reason being is because in this area right through here is the ozone layer. And that ozone layer is not really that high up. That ozone layer is what blocks a lot of that radiation. So when we get UV radiation down, remember 95% of that is blocked. And how much of it makes it through? 5%. And that is what protects us. And it's not that high up. It's really not that high up. And so we want to make things pretty safe. This is why when we produce a chemical called CFC, or chlorofluorocarbon, That stuff destroys ozone, so we stopped putting it into cans and other things. And it's not a natural gas, it's actually man-made. And we found out that it destroys ozone, and so we don't want it in the air anymore, so we stopped producing it, putting it into cans. But the reason why that this temperature changes is because it goes up. And the reason why it goes up is since it blocks a lot of this radiation, the ozone will start producing heat, and guess what happens to the layer above that? It gets hot. It starts warming up. And that's due to the ozone layer. What else do we know about the stratosphere? We know that we have balloons that we'll put up here that will take measurements of the atmosphere, like humidity, barometer, temperature, different wind speeds, and other things. It will take temperature, takes all that data, and then we collect that data to find out what's going on with the weather. And we make a lot of our weather predictions from this. This line right here is also known as the stratopause. Good. So remember, it always takes the name below, strato, and then puts pause after it. So this is a pause or a break where the temperature will stop, and it makes a very striking change. So in this case, when you get up into the mesosphere, guess what? It cools back down again. And this is the mesosphere. Okay. There's one thing here that I didn't tell you. I have a 20 right here. That 20 represents 20 miles. There's an interesting little fact about that. Up above that is 1% of the atmospheric gases. Below that, 99% of all of the gases in the atmosphere can be found below 20 miles. The same. Hang on a second. Will be found. So from here on down, we have all the main gases. The most prevalent gas is nitrogen. There's 78% nitrogen, 21% oxygen. Then there's like 0.93% argon. Then after that, everything is just very, very, very small. So carbon dioxide, methane, hydrogen, helium, those gases will be found there too, and they're very, very small percentages. So everything is found from here. Here, 20, what, maybe like Pleasant Grove? Maybe the point of the mountain? So from the point of the mountain to us is where the majority of all of the gases of the atmosphere reside, within that first 20 miles. So you take that, stand it up on top above us, you go up 20 miles, you're going to find 99% of all the atmospheric gases there. Once you go beyond that, you drop down into the 1%. So there's hardly any atmosphere up above here, so it gets really, really, really thin. We get up in the mesosphere. Do we know anything about the mesosphere? No, we don't know much about the mesosphere. Why don't we know much about it? We can't, so we don't get balloons up there, and we can't fly in it, so it's kind of like this pass-through area. Ships and rockets and other things can get through there, but we don't really get much information. We do know a few things. Yeah, we don't know much about it. We do know that sometimes we get some clouds up in there, but that's about it, and they're super thin, and mostly it's just ice crystals. We do know that we have a little thing called sprites. Sprites is a lightning that actually shoots upward and out to space. They're kind of cool looking. And we also know that in the mesosphere we get all your falling stars and stuff that you see. This is where they will more than likely burn up, is right in through here. So they'll fall in, and so those shooting stars you see is in the mesosphere. Guess what happens as we go up even farther? It gets hot again. This is known as the thermosphere. Good job. By the way, this is the mesopause. This one is called the thermopause. And really, there is a pause there, but there isn't, because there's really no definite boundary between these two layers. But we do have the thermosphere. Why do you think it would be called a thermosphere?
Very, very hot.
Yeah, it is hot. It's very hot. Okay, we know that temperatures up here can get over 1,000 degrees Celsius. So it gets pretty hot, but it won't feel hot. It will actually feel really cold. So if you remember what temperature is how fast particles are moving. So all that means is that these particles are moving super fast. If there are a lot of them, then yeah, it would be really hot. It wouldn't be very pleasant. This is where we find the aurora borealis. Okay, so all the northern lights, all those pretty lights that we see in the northern hemisphere. And then we get up here to the exosphere. The exosphere doesn't really have a boundary. Once you get past that, you are pretty much into space. In fact, in the exosphere, you're still technically in our atmosphere, but it definitely will not feel like it. We know that this is where like satellites exist. Also, spaceships or spacecraft. The International Space Station will be found there as well. And another interesting thing is that the temperature just keeps going up. So now we have temperatures here over 2,000. Yeah, it's just going to get hotter. And you got space, what's going to happen? Temperature is just going to keep increasing. Okay, so satellite spaceships, that's the exosphere. There really is not any definite boundary. So you'd mentioned earlier, and I told you it goes out to the moon. We have found the exosphere's boundary between us and the moon before. Sometimes it's shorter, sometimes it's farther. It just totally depends. Yeah, and it's really hard to actually identify where it's at. So a lot of times you'll see books, they won't even talk about the exosphere. Now, right here I have a 60. Do you know what that 60 is for? That is 60 miles, and what's significant about the 60 miles? Yeah. Okay, yeah, 60 miles away from the Earth, but that number actually has a meaning. Okay, this is where NASA says officially space begins. So once you get up past 60, NASA considers that as space. So you're actually out in space.